So we have started the last chapter in our face-to-face lecture, that is chapter number 26, Standard Client Server Protocols. So far we have discussed World Wide Web and HTTP, FTP, electronic mail, and Telnet. The last two protocols are left, that is Secure Shell and the Domain Name System. So we will start with Secure Shell, which is also called SSH. As the name implies, it is also called Secure Application Program that can be used for purposes like remote logging and file transfer. So you know that for file transfer we are using FTP, and for remote login we are using Telnet. So this Secure Shell is used as a secured application program both for remote login and for file transfer. There are two versions of SSH. We have SSH1 and SSH2, which are totally incompatible. So let's start with Secure Shell. So here you can see these are the components of SSH, that is Secure Shell. We have three components. The first one is SSH trans. As we know that TCP is not a secure transport layer protocol, so SSH first uses the protocol that creates a secure channel on top of TCP. So this is our TCP. On top of it we have SSH trans. So this new layer is an independent protocol and it is known as SSH trans. Now when the procedure implementing this protocol is called, the client and the server first use the TCP protocol to establish an insecure connection. Then they exchange several security parameters to establish a secure channel on top of TCP. Next we have SSH authorization protocol, or we can say SSH authentication protocol. Now once the secure channel is established between the client and the server is authenticated for the client, SSH will call another procedure that can authenticate the client for the server. So the client authentication process is SSH and is very similar to SSL, that is Secure Socket Layer. We have discussed about Secure Socket Layer in the previous chapter. And the next one is SSH Con. This is SSH Connection Protocol. Now once the secure channel is established and both the server and the client are authenticated for each other, then SSH can call a piece of software that implements the third protocol, and this is called SSH Con. So one of the services which is provided by SSH Con protocol is multiplexing. It takes the secure channel which is established by the two previous protocols, and then it led the client to create multiple login channels over it. So each channel can be used for a different purpose, such as for remote login, for file transfer, and so on. So we have two basic applications of this secure protocol. These are remote login and the file transfer, as we have discussed in the beginning. Now when we say SSH for remote login, then several free and commercial applications use SSH for remote login, and among them one is PUTTY, which is a client SSH program, and it can be used for remote login. And there's another application program which is called Tectia, which can be used on several platforms. The next one is for file transfer. Now one of the application programs that is built on top of SSH for file transfer is the Secure File Transfer Program, that is SFTP. So the SFTP application program uses one of the channels which is provided by SSH to transfer the files. Now this figure shows port forwarding. So one of the interesting services which is provided by SSH protocol is port forwarding. So here we can use the secure channels which is available in SSH to access an application program that does not provide security services. So applications such as Telnet and Simple Mail Transfer Protocol can use the services of SSH port forwarding mechanism. So here you can see that the SSH port forwarding mechanism creates a tunnel through which the messages belonging to other protocols can travel. So for this reason, this mechanism is sometimes also called SSH tunneling, because here we are using tunnel. Now the FTP client can use the SSH client on the local site to make a secure connection with the SSH server on the remote site. Now any request from the FTP client to the FTP server is carried through the tunnel, and it is provided by SSH client and server, and any response from the FTP server to the FTP client is also carried through the tunnel provided by the SSH client and server. This figure shows SSH packet format. Here we have 5 fields. The first one is the length, the second is padding, then we have type, data, and CRC. Now from padding to CRC, these fields are encrypted for confidentiality. Encryption, you know, converting the plain text to ciphertext is known as encryption. And at the receiver side, we convert the ciphertext back to plain text, and this is called decryption. So this is done for security point of view. Now here, the length field defines the length of the packet, but it does not include padding. In the previous cases, we have seen that padding was included in length, but in this case, padding is excluded. Now 1 to 8 bytes of padding is added to the packet to make the attack on the security provision more difficult. And the cyclic redundancy check field is used for error detection. The type field designates the type of the packet. used in different SSH protocols, and the data field is the data which is transferred by the packet in different protocols. So here you can see this is secured. Next we have domain name system. Now as we know, to identify an entity, the TCPIP protocol uses the IP address, and this IP address uniquely identifies the connection of a host to the internet. And we, the people, prefer to use names instead of numeric addresses because it's difficult for us to remember addresses and it's easier for us to remember names. So the internet needs to have a directory system that can map a name to an address, and this is very much similar to the telephone network because a telephone network is designed to use telephone numbers, not names. So people can either keep a private file to map a name to the corresponding telephone number, or they can call the telephone directory to do so. So whenever we have to save a telephone number, we save it by a name. We have an option over there. So the internet is so huge today, and a central directory system cannot hold all of the mapping. So in addition, if the central computer fails, the whole communication network will collapse. So we have a solution over here that instead of saving everything in a central directory, let's have a distributed directory. So we distribute the information among many computers in the world. Now in this method, the host that needs mapping can contact the closest computer holding the needed information, and this is called domain name system. Now in this figure, we can see how the TCP/IP uses a domain name system client and a DNS server to map a name to an address. A user wants to use a file transfer client to access the corresponding file transfer server, which is running on the remote host. Now the user knows only the file transfer server name. Suppose it is any name like a.com. So the TCP/IP suite needs the IP address of the file transfer server to make the connection. Now, first of all, what will happen? The user will pass the host name to the file transfer client. This is the first step. The second step is the file transfer client passes the host name to the DNS client. Next, each computer, after being booted, knows the address of one DNS server. The DNS client sends a message to a DNS server with a query that gives the file transfer server name using the known IP address of the DNS server. Next, the DNS server responds with the IP address of the desired file transfer server. Then the DNS server passes the IP address to the file transfer client. And finally, the file transfer client now uses the received IP address to access the file transfer server. Now, the purpose of accessing the internet is to make a connection between the file transfer client and server, but before this can happen, another connection needs to be made between the DNS client and the DNS server. So we need at least two connections in this case. The first is for mapping the name to an IP address, and the second is for transferring the files. Next we have namespace. Now the namespace, basically it is the name, and this name must be unique because the addresses are unique. So a namespace that maps each address to a unique name can be organized in two different ways. The one is flat and another is called hierarchical. Now in a flat namespace, our name is assigned to an address. A name in this space is a sequence of characters without structure. So the names may or may not have a common section. It has no meaning. The main disadvantage of a flat namespace is that it cannot be used in a large system such as internet because it must be centrally controlled to avoid ambiguity and duplication. The second is hierarchical namespace. In this, each name is made up of several parts. The first part can define the nature of organization. The second part can define the name of an organization. The third part can define the departments in the organization, and so on. So it is hierarchical in nature. Let's see how it looks like. This is our domain namespace. We have a root, then we have top level nodes, and then so on. So to have a hierarchical namespace, a domain namespace is designed. Now in this design, the names are defined in an inverted tree structure with the root at the top. Now this tree can have only 128 labels. It will start from label 0, it is the root, and it will go up to label 127. So this is important to remember, that it can have 128 labels only. The root label is assigned as label 0, and the last label will be label 127. So it will start from 0 up to 127. Total 128 labels are there. Now in this we have label. Now each node in the tree has a label, and it is a string with a maximum of 63 characters. So the root label is a null string, or it is an empty string. Now DNS requires that children of a node have different labels, which guarantees the uniqueness of the domain name. Next we have domain name. Each node in the tree has a domain name, and it is a sequence of labels which is separated by dots. As you can see in this example, we have a computer dot b department dot top university dot edu. So a full domain name is a sequence of labels, and these labels are separated by dots. These are individual labels: edu, top university, b department, a computer. So we will start from bottom and we will go up to root. Now, this is our domain. A domain is a subtree of the domain namespace. The name of the domain is the name of the node at the top of the subtree. You can see this figure. Here we have a root server. We have edu server, com server, us server, and then we have fhda.edu, bk.edu, mcgraw.com, irwin.com, and so on. So these are the hierarchy of name servers. Now the next concept is zone. Now we know that the complete domain name hierarchy cannot be stored on a single server, so it is divided among many zones. So what a server is responsible for or has authority over is called a zone. So we can define a zone as a contiguous part of the entire tree. Now if a server accepts the responsibility for a domain and does not divide the domain into smaller domains, then the domain and the zone refer to the same thing. The server makes a database called a zone file, and it keeps all the information for every node under that domain. So if a server divides its domain into subdomains and delegates part of its authority to other servers, then domain and zone refer to different things. Now the information about the nodes in the subdomains is stored in the server at the lower levels, with the original server keeping some sort of reference to these lower level servers. So the original server does not free itself from the responsibility totally. It still has a zone, but the detailed information is kept by the lower level servers. Now these are the generic domains. We have a root label, and then we have Arrow. This is for airlines and aerospace. Next we have Biz. This is for businesses or firms. Com, it is for commercial organizations. Corp, this is for cooperative organizations. Edu, this is for educational institutions, like you have @scu.edu.sa. So scu.edu.sa. Edu is for educational organizations. Then we have gov. Gov for government institutions. Info, it is for information service providers. Then we have int, it is for international organizations. Then MIL, this is for military groups. This is for museums. Name, this is for personal names, for individual names. Net is for network support centers. ORG is for non-profit organizations. And PRO for professional organizations. So now if under EDU we have UCI, So what will be the domain name? The domain name will be uci.edu. We will start from bottom and we will move upwards. So this is generic domains. Now we have country domains. The country domain section uses 2-character country abbreviations. For example, US for United States. Now second labels can be organizational or they can be more specific national designations. So here in this example, the United States uses state abbreviations as a subdivision of US. So we have usi.ca.us. So it can be translated to University of California, Irvine, in the state of California in the United States. Next we have resolution. Resolution means we are mapping a name to an address. So whenever we are mapping a name to an address, it is called name address resolution. Now DNS is designed as a client-server application. So a host that needs to map an address to a name or a name to an address will call the DNS client, and it is called resolver. So the resolver accesses the closest DNS server with a mapping request. So if the server has the information, it satisfies the resolver. Otherwise, it either refers the resolver to other servers or it will ask other servers to provide the information. So after the resolver receives the mapping, it interprets the response to see if it is a real resolution or it is an error. And then it will finally deliver the result to the process that requested it. So there are two types of resolutions. It can be either recursive or iterative. So this figure shows you recursive resolution. Here we have an ISP, we have a root server, and we have a network. Now here we assume that an application program is running on a host, and the name of that host is some.anet.com. This is our source. And it needs to find the IP address of another host, which is named as engineering.mcgraw-hill.com. So this is the destination to send a message to. Now the source host is connected to ANET ISP. The destination host is connected to McGraw-Hill network. Now the application program on the source host will call the DNS resolver. It is the client to find the IP address of the destination host. Now the resolver, which does not know this address, it will send the query to the local DNS server. And the local DNS server is dns.anet.com. It is running at the ANET ISP site. This is our event number 1. Now we assume that this server does not know the IP address of the destination host either. So it sends the query to a root DNS server whose IP address is supposed to be known to this local DNS server. This is our event 2. Now the root servers do not normally keep the mapping between names and IP addresses, but a root server should at least know about one server at each top level domain. Now in this case, a server responsible for com domain. So the query is sent to this top level domain server, and we assume that this server does not know the name address mapping of this specific destination, but it knows the IP address of the local DNS server in the McGraw-Hill company. So the query is sent to this server. This is event number 4, which knows the IP address of the destination host. Now the IP address is sent back to the top level DNS server. This is event number 5. Then back to the root server, event 6. Then back to the ISP DNS server, which may cache it for the future queries. And finally, back to the source host. So this is called recursive resolution. Now the next one is iterative resolution. In iterative resolution, each server that does not know the mapping sends the IP address of the next server back to the one that requested it. So here we see the flow of information in an iterative resolution in the same scenario as we have seen just now. So normally the iterative resolution takes place between two local servers. The original resolver gets the final answer from the local server. The messages here at event 2, at event 4, and event 6 contain the same query. So the message shown by event 3 contains the IP address of the top level domain server. The message shown by event 5 contains the IP address of the McGraw-Hill local DNS server. And the message shown by event 7 contains the IP address of the destination. So when the init local DNS server receives the IP address of the destination, it sends it to the resolver, and this is event number 8. So this was all about different types of protocols that are working at the application layer. We have discussed the standard client-server protocols in this lecture. This is chapter number 26, and with this, your course is completed now. Now, I want feedback from your side. Just have a quick review to all the chapters that are in your course, and please mail me. Mention the topics in which you are having problem, so that in our next face-to-face lecture during revision week, I will consider those topics first. And then, if time permits, I will try my level best to cover the rest of the topics also. So I want mail from your side that which topics you want me to discuss first. Another important thing that I want to tell you is, it is from the coordinator side. He has said that we should make an announcement I found some confusion in routing. Okay, no problem. Aida, please mail me. Okay, mail me. Okay, you have problem in chapter 20 routing, so mail me. I will discuss it first. Now there's another announcement, and this is from coordinator side. He said that chapter number 1, 2, and 3, these chapters contains very basic topics, elementary topics, and the topics of these chapters are discussed in detail later on also. So in exam, chapter 1, 2, and 3 means don't focus on these 3 chapters, chapter number 1, 2, and 3. Focus on the chapters which are after chapter number 3, because these 3 chapters contains very basic questions. What about numericals? For numericals, there is no information so far. There is no information regarding numericals so far. If you want to ask, you can ask him directly. Okay? Mail him, put my name in CC. To the instructors, there is no information regarding numericals. So we still have time. If you have any doubt, any query, you may ask. And I want mail from your side. And yes, one more thing regarding Telnet. When we were discussing Telnet in our face-to-face lecture, we have discussed that whenever we are using Telnet, we have to give IP address. So these days, we are working with IP addresses also and domain name also. In earlier cases also, we were using domain names. And these days also, either we have to give the IP address or we have to give the domain name. So without IP address, if you want, then the IP address should not be given, neither IP address nor domain name should be given, and the Telnet will work, it will not work. With Telnet, you have to give IP address or you have to mention the domain name. Then only it will work. So this was all about this subject IT 210. Inshallah, we will meet in next face-to-face lecture in revision week. And I'll try my level best to discuss most of the topics, because it's difficult to discuss all of the topics, but I'll try my level best to give you the review, to discuss the major topics first. Yes, regarding final project of week 14, what you have to do, just compile all the objectives. You have done objective 1, objective 2, 3, and 4. Just take them and paste them in a single file. You have already submitted these 4 objectives. You have to collect all these 4 objectives in one file and then submit it. This is what you have to do in week 14 project. Only, yes. Now just explain the basic concepts in the router, please. Means chapter number 20. Yes, Aida, you want me to discuss chapter number 20? Okay, let me upload it first. The slides cannot be loaded because of some error. So let's discuss the general thing about routing, as you have said. See, whenever we are talking about internet, the goal of the network layer is to provide the datagram. Now this datagram is transmitted from the source to the destination. If we have just one destination, and if we have more than one destination, it will be from source to destination. So if a datagram is for only one destination, this is called one-to-one delivery, and we call it unicast routing. One-to-one is unicast. And if the datagram is for several destinations, that is one-to-many, then it is called multicast routing. Now we have various routing algorithms, and we have discussed them one by one. If you remember in class, we have discussed about distance vector routing, and we have discussed about Bellman-Ford equation also, because the heart of distance vector routing is Bellman-Ford equation. So we have discussed it. The slides are not uploading, otherwise I must have shown you the example also. We have discussed about spanning tree also, how the spanning trees were created, and we have seen the forwarding tables, because in case of routing we have forwarding tables which needs to be created. So this is what we call routing. Means the routing of datagrams from the source to destination. Now this is done at the network layer. This is done at the network layer. So if we are routing the datagram from one source to one destination, one-to-one, it is called unicast routing. And when we are forwarding the datagram from one source to multiple destinations, that is one-to-many, it is called multicast routing. We have several algorithms also. Inshallah, I will discuss in our face-to-face lecture by showing you the examples also. This time, due to some problem, the slides cannot be loaded. Is it okay? Is it clear? Yes, anything else? Let me try if the slides can be loaded, because still we have 10 minutes. Now it's loaded. Unicast routing. Yeah, in next is virtual lecture. Yeah, okay, no problem. I will explain it in virtual lecture then. No problem at all. So here we have, yes, we have two types of routing, unicast and multicast. Now, if you remember this, we have created the least cost trees, the least cost tree for each and every node. We have to find out from where we get the least cost. We have some routing algorithms, distance vector routing, in which the distance was created. And the heart of this algorithm is Bellman-Ford equation. So this is our Bellman-Ford equation, the diagram. Now, the distance vector is created for each and every node. This is for node A only. Now here we have distance vector for each and every node. So no problem, I will explain it. Then we have discussed about linked state routing also. Least cost tree, where we have a spanning tree. This is the path vector routing, where we create path vectors. These are the forwarding tables which are created in Routing Information Protocol, RIP. Okay, so I will explain it, no problem. Again, I will explain it to you. Okay, see you in next face-to-face lecture, inshallah. Till then, take care all of you. Assalamu alaikum.